Hello everyone. So today we are going to solve 1306, which is jump game 3. So it says that we are given an array of non-negative integers. You are initially positioned at start index, and when you are at index I, you can jump to I plus array of I or I minus array of I. Okay. Check if you can reach to any index with value 0. Uh, okay, that makes sense. So basically, we are given a start index. So if I'm given 5, so that's 0, 1, 2, 3, 4, 5. So I'm here. So I can take a jump of plus 1 or minus 1. Okay, so let's say I'm here 3. So I can take a jump of plus 3 or minus 3. So I'm going to keep doing this until I'm at a point where I reach this. If I cannot, uh, okay, I just return true or false. That's it basically. Okay, that makes sense. Uh, so the idea is, I think this is pretty much straight grilly sort of problem, I guess. I don't know if that's the right word to say, but so um, I'll need a queue where it will take in integers, queue, right? And what I'm gonna do is I'm gonna add my start index there, right? And then what I'm gonna do is while my queue is not empty, uh, I'm gonna do a queue dot poll. So that's my int current index, right? And then what I'm going to check if my array of current index, if that is equal to 0, that means that's my answer. So I'm going to return true, right? Otherwise, if that's not the case, right, I'm going to generate new indexes, int index 1, which will be uh, current index plus array of current index, right? And then I'll generate index 2, which will be the subtraction of this, right? Now I gotta check if index 1. So since I'm adding, it needs to be less than array.length so that it's valid. Basically, that's the valid check, right? I'm gonna do q.add index 1. Similarly, for index 2, since it's subtracting, it has to be greater than equal to 0. That's when I do this, okay? And then at the end of it, if I come out and I entered it, that is false. One thing here is that I'm going to be an infinite loop here because I'm just going to keep jumping. So I need to make sure I don't visit an index which I've already visited. So what I'm going to do is I'll have a hash set which is going to keep track of the indexes I have visited, seen, right? And then what I'm going to do is scene.add start. Oh, actually not needed. Yes, let's put it. I think that's better because, yeah. And then whenever I'm doing, I'm going to check this, and then it is not seen, and then seen dot it contains this index 1, and then I'm going to add seen dot add index 1. Same thing I'm going to do here as well. Oh, yep, let's run. Awesome, this works. In terms of time and space complexity, I would say uh, I'm going over the queue. um, yeah, I think it's going to be O of n. uh, the reason being, I just add 1 to the queue, I generate the possible indexes, and I don't add an index which I've already visited, right? So at max, I'm going to visit all the elements of the array. So time is this. In terms of space, I'm taking a queue which will be O of n and scene which will be also O of n. So this is basically n plus n to n. So this is also going to be O of n. Yep, that's it. All right, thank you.